Hi guys, Chris from Restoration Rehab here. Thought I'd run you through a quick video on some dye-penetrant testing. So we are located in Victoria, Australia, and one of the regulations we have to comply with down here is that any welding in structural areas of a vehicle or structural changes in the vehicle have to be flaw checked. So one of the best ways to do that is to use a dye-penetrant system. And while that's fairly easy to do in itself, probably one of the harder things is recording it all and reporting on it all. So I thought I'd take you through some of the details of it all and how we do it. So to start with, obviously the first thing you need to do is make sure that you've got all your areas clean. So obviously if the area hasn't been painted, let's have a look at this one down here, then you're pretty much good to go. We'll just use the cleaner on those sort of areas to start with, but anywhere that has actually sort of been finished and painted to some extent needs to go all the way back to bare metal. So you can see here that it had been primed in a few spots, and I've had to take it all the way back to bare metal, and we've used a combination of some wire wheels, and we've used also some flapper discs to do some actual shaping and finishing work. So essentially it's in the shape now and finished, ready for painting, and this is almost the perfect state to actually do the dye pen. Alright, so step one with your dye pen is really to work out all the areas that you're going to actually analyse. And like I said, for us here in Victoria, I need to analyse every single one of the welds that is joining essentially a structural member. So we've got a C-notch system happen here on the back of this 53 F100 chassis. So basically every single weld on this needs to be done. The only welds that really aren't applicable is probably, well, to be honest, actually, I don't think I've got anything. Oh yeah, probably things like the brake tab down here. Not a structural component, doesn't really matter, but the spring perches, the shock perches, the panhard rod mount, all of this actual modification over here and the 4-bar link mounts at the front here all need to be analysed. Okay, so what I like to do is I like to actually label all of my welds before I start, photograph them all before I start. So you can see a whole lot of lines here and codes. And it's a pretty simple code, it's not really complex. What I do is I write on a bit of paper areas. So rear chassis for this is 1. I think I've labelled the panhard rod, the 4-bar link mount as 6. We might have done the spring perches as 3s, etc. So the number at the start essentially is identifying an area for me, so that when I take a photo up close here, I don't have to worry too much about identifying where it is. You can tell by the number. L indicating left and right. And then we've got a couple of codes. O for outer, I for inner, U for upper, D for down. The reason I've done down instead of lower is because I'm using L for left. And then we've got F for forward, and if we go over here to one of these ones, B for backwards. So essentially each of these is going to have a code, so I can look at any one of them and know really what it is. So I've got 1 chassis rail, left hand side, outer, upper, and then on these ones here, because it's one weld essentially running this whole length that I need to analyse it all, I've broken it into sections about 200 mil long so that I can analyse each one or photograph each one independently. So you're looking at the 4th one here, and they're all numbered from 1 at the forward side to rearward. So essentially number 4 means I'm looking at the 600 to 800 mil point of the weld. Okay, so we've got all labelled. Now first step is to clean the area. So all of your dye penetrant kits should come with a cleaner. Basically it's a Prepsol in a can. Anything that will actually draw out chemicals, etc. Any residual shit that's left in any of the pockets is perfect, but we're using the Chemtools system here for this one, so you pretty much got this Prepsol metal cleaner degreaser system, and it is literally just a spray on wipe off. So let's have a go here. This one's all been cleaned already, but we'll do this area again anyway. So spraying it on, just popping that there out of the way, and then we're wiping off. And really shouldn't see any difference here, but anything that was there in terms of waxes, greases, etc. that are going to prohibit the developer from soaking in is what you're trying to get rid of here. Once you've done that spray, you probably want to leave it for at least a couple of minutes just to make sure that any additional fluid that's got trapped in pockets, etc. has got time to evaporate and dry out, so again the developer can soak in. Alright, so we've cleaned it. Now we're on to the next step. Stage 2 of the system is the actual dye penetrant. It is a red dye in these ones, It is quite thin, and the purpose of that is so that it soaks into all of these areas. You don't have to spray a heap of this. You don't want this really dripping everywhere, but you do need to make sure you've got enough over all of the areas. And the trick with this stuff is that you want to put it on and you want to leave it on for about 15-20 minutes. Sometimes they say up to half an hour, just to ensure that it's soaked into everywhere it needs to soak into, and then we wipe it off again. So let's spray a bit on and we'll come back in 15 minutes to wipe it off. And that's about all you really want to put on, you know. Much more than that, I mean, look, we've got a little pocket here that probably needs a tiny bit more in it. Much more than that, you can see it starts to actually run, and you're going to end up with truckloads on your floor. All right, so that's about all you really need. So we'll stick with just that area at the moment. Usually I'd probably do the whole thing, and then we'll develop the whole thing because I can see all the marks. But we'll just do this area for now. Okay, we've let that sit for about 15-20 minutes. Let it soak in, and then we've wiped it all off, and we've thoroughly wiped it off. I mean, don't be too scared about cleaning this thing too much with your rag. As long as your rag hasn't got anything on it in terms of your prep soles, degreasers, anything, as long as it's just a dry, clean rag, that's exactly what you're trying to do. You're trying to get rid of all of the surface stuff. This penetrant will have soaked into all of the little cracks and crevices. That stuff you won't get out with the rag. All right. So we've wiped all this off now, and we're on to the third stage. Third stage is your developer. It's like a white powder, and the idea of the white powder is it sprays over the surfaces and soaks out the last of that red dye that's been trapped in there. And basically anywhere that shows up red, obviously there's been dye pooling. And you want to go along and have a look at all of these. Not all of these are going to be actually flaws. Some of these are just literally going to be pockets where it's trapped dye and you couldn't wipe it out. But what you're mainly looking for is cracks. Cracks are really what you're actually solving for here. So let's go ahead and spray some of this. Again, we'll just focus on just this area for now. So trick with this stuff is you don't want to spray too much, just a little bit, and then let it actually dry off. And you'll see as it dries off, it goes white. Come in a bit closer. And you start to see it pulling out dye. So you can see this weld up the top here. Obviously, I'm going to say that the welder in this area maybe had a gas flow issue, because there's a hell of a lot of pitting. We'll come along here, again another pocket, and there's actually a really good example. You see off the back of that pocket there's a little tail coming off it. That's the first of your flaws. Alright, so that actually is maybe a hot cold start point, but either way it's showing up as a near on crack. So we're going to have to grind that out and re-weld that area. Come down here. These ones, pulling dye out, yep, but they're all really pretty much just pockets. They're just spots where the dye's got trapped. And that is dye penetrant. So the idea, like I said, is for Victoria, it's a requirement for engineering approval to certify all the welds. Idea being, we can't really do destructive testing, which is ideally the one that you do want to do to get in and actually check penetrations, etc. So we do the best we can, which is a flaw check to make sure that we haven't got anything that's going to initiate a crack and cause a fatigue issue down the track. Hope that's been helpful. See you later.